Let's go live.
Okay, so before we get started with today's lesson, we're having an exam on Wednesday, and we're going to review for it on Tuesday, and we will not have school on Monday because it's President's Day. So we will be honoring Presidents Washington and Lincoln, I think, is who originally started President's Day.
Yes.
It's close to their birthday. It's all, for all presidents now, but I think it started with those two. So we will be honoring Washington and Lincoln. Lincoln in particular, a man who walked 5 miles to borrow a book from the library so he could learn. We will be honoring him by not attending school on Monday. So no school on Monday, review on Tuesday, exam on Wednesday. Yes, ma'am?
Today?
Perfect, thank you. Okay, so we're going to talk about recursive formulas, which are sort of related to what we did yesterday with your exponential formulas, with one tiny little change. A recursive formula works by doing some math to the numbers in front of it. So a really popular, maybe I shouldn't say popular, famous recursive formula is this one. This is referred to, anybody know what this is called? That sequence of numbers?
The second number plus the first number.
Well, yeah, what's it called?
Geometry.
It's called a Fibonacci sequence, obviously.
what?
The Fibonacci sequence.
That's what I was thinking.
Why is it in total?
Because the mathematician that came up with it was an Italian named Fibonacci. But Elijah's already figured out what the pattern is. The first two numbers are ones, so if you do 1 plus 1, you get 2, which is the third number. Then you do the second number plus the third number to get the fourth number.
Fine.
Then you do the third number plus the fourth number to get the fifth number, etc. So this is called a recursive formula or recursive sequence because it uses the number in front of it to make the sequence. You could do simpler ones than the Fibonacci sequence. For example, that's a really simple.
No, what's Parker's number? Sorry.
1418.
Thank you.
Really simple example of a recursive because you are taking the previous number and adding 2 to it. So if I start with 2 and I add 2, I get 4. You take that and add 2 to it, you get 6. You take that and add 2 to it, you get 8, etc. So that's a really simple example of a recursive formula.
Extra dots.
Okay. All right, thank you, ma'am.
Thank you.
Better?
Thank you.
No problem. You type A lunatics. Your dots aren't the same size.
So you just use the first number.
It doesn't have to be the first one. It could be 2 in front of it. That would look weird, but you could do it. It could be multiple numbers, like add the first 3 numbers to get the fourth number. All recursive means is that you use some of the previous numbers to get the next number.
Okay, so with the first one, how it's 1, 1, would you add 0 plus 1?
No, because I didn't start with 0. I did 1 plus 1 to get 2, so first plus second gave me third. Okay, so let me show you how you would do one of these. Let's find the first 5 terms of the sequence. Lordy.
Yeah.
Okay.
I promise,
Wait.
much like Mrs. Taylor in the morning, it looks scarier than it really is. Yes, sir.
Why is the the end not on the bottom? That's the top. Like how it ends like that.
Oh, okay, good question. So we talked about this a little bit yesterday whenever we did the exponential functions. A1, that's a subscript, so we read it as A sub 1. This means the first term in the sequence. This means the nth term, whatever number n is. So if I replaced n with 12, it'd be the 12th term in the sequence. This is the part that looks scary. But what does n minus 1 mean?
It means the number minus 1, like the nth term.
Uh-huh. So put that in English. The nth term minus 1.
So 7 minus.
So if I said if n was 12, the 12th term,
It'll be 12 minus 1.
which would be,
11.
so the 11th term. So this just means the previous term. So what this is saying, this part right here, what that is saying is, to find the next term, you do the previous term minus 12. So let me do a quick little table here for you. Oops. Okay. So we're going to say this is n, this is extend this a little more. Are you bothered that my lines don't match?
Yeah, I was
exactly?
just thinking that it was really making my eye twitch, and I was like, he's not going to redo that.
Nope, not going to redo it.
He's a boss.
Yeah, I think so.
And notice how the two vertical lines aren't the same length.
Yeah, I know.
Mm-mm.
Yeah,
That's
the
just for
second
you
one, and
type A
he's-
people. You are
he's
welcome.
doing that
Mhm.
because Emily always corrects him.
So
Well, I'm with you on that one.
when n's 1, that would be the first term in the sequence, right? Now the goal here, I'll scroll back up to the directions, was to find the first 5 terms. So my first 5 terms would be 1, 2, 3, 4, and 5. What's the first term in the sequence?
7.
7. It says so right here. First term is 7. So I'm not doing any math on the first one. It's just 7. The problem told me the first one was 7. We're good to go. Okay. Now what it says is the second term is the previous term minus 12. So I'm looking at n equals 2. What was the previous term? 7. So I'm going to do the previous term, which is 7, minus 12, which gives me
Negative 5.
-5. Very good. Okay. Let's find the third term in the sequence. You take the previous term, which was -5,
Minus 12.
and subtract 12, which is
negative 17.
very good. To find the fourth term, I take the previous term and subtract 12,
Which is going to be 29.
-29, good.
Yeah, negative.
And finally,
Negative 41.
there we go. So the first 5 terms in the sequence are 7, -5, -17, -29, and -41. Would you describe this sequence as being geometric or arithmetic, or neither? Why arithmetic, Emily?
Because it goes down by the same amount.
Exactly right. It's going down by a constant amount. The constant amount in this case would be 12. It's subtracting 12 every time.
That between the page does copy so copy.
You copy my
Why are you so
all
good
my
at
stuff.
Hmm?
Because
Why are you so good at that?
Is what, Riley?
You can copy
Practice.
all my stuff.
Well, it's fine.
You have to copy this from here.
No, I have
If you do anything for 20 years, you'll get good at it eventually, I promise. Okay, let's try this one. As usual, I will email you the notes when I'm done. I mean, when I'm finished. Oof. Please don't tell anybody that I said it when I'm done instead of when I'm finished.
Can that be in parentheses?
Which
Like you
part?
did the last time?
It could be. It doesn't have to be. She asked, does the n greater than or equal to 2 have to be in parentheses? And the answer is, it doesn't have to be. You can.
Makes you feel more
this
confident.
is 4a and subscript n minus 1.
Mm-hmm.
And then what's the little line after that?
That's a comma.
Oh,
I'll take. You two are so gripey. There. Happy? Okay, so let's talk about what this one means. What's the first term? 3. And what do I do to get the next term?
Can you graph it like we do?
I'm adding 4.
Adding 4?
Subtract.
Wait,
3.
what did you ask?
How do I get the next term?
Subtract. You multiply that.
I'm multiplying. This part right here, 4a to the n minus 1. Remember, a to the n minus 1 is the previous term. So this is 4 times the previous term. So the last one I was subtracting 12 every time. This one I'm going to be multiplying by 4 every time. See if I can make a prettier table for you people. It's about the same length, right? Sure.
Is that a attached to the 4?
Yes, it's 4 times a. Okay, so my first term, no math required because the problem gives it to me. My first term is 3. Now the goal was to find the first 5 terms. 2, 3, 4, 5. Not quite long enough, but I'm sure nobody will make a big deal out of that, right? What do I do to get the next term?
You do 3 times 4.
Previous term, which was 3, times 4.
Which is 12.
Actually, I guess if I wanted to follow it exactly, I'd do the 4 first and then the 3, which is 12. Yes.
Why on number on the 1, that's the a n equals 4a n minus 1. Why is there a line?
Because I don't have to do any math for that one. The problem gave me the first term, just said it was 3. So I'm just doing a line to show I don't need to fill that in.
What?
Okay, the third term, I would do the previous term times 4. So 4 times 12.
Which would be 48.
Then I would do 4 times the previous term.
Which would be 192. Wait, 48. Wait, yeah, 192.
I think you're right. And that's going to be like 900 something, right?
192. And then 4 times 1.
Be 1,000 minus 40, so 960.
Yeah.
Is that right?
768.
I nailed it. I was so close. Really, 768?
Yes.
How did I mess up on that? I don't think it is 768. Is it? Oh, it's times 4, not times 5. Derp.
Why is it not 5?
What do you mean?
Like at the bottom, yes, it has 4A and it's net, but why, like on the end, why aren't you so much like
Yeah, that was the mistake I made. That's why I thought the answer was going to be close to 1,000 because I was multiplying it by n. It's the 5th term in the sequence, but we're multiplying by 4. That's the mistake I made. So our first 5 terms are 3, 12. Is this geometric, arithmetic, or neither?
geometric?
That's geometric, and the constant we're multiplying by every time is
4.
4. So recursive functions can be arithmetic or geometric.
Can they be both?
The only one that we thought of yesterday that could be both is if you have the same number every time. If your sequence is 5, 5, 5, 5, 5, then it could be both. A recursive function could be neither. We'll get into that a little later. All right, I'm going to give you a couple to practice.
Okay.
Oops, I'm going to write in highlighter because that's the way I roll. Practice. And I'm going to write these right next to each other, but you will probably need more space in your notes than this. So the first one, we're going to say the first term is 2, and the sequence is going to be Yep. Oh, do you know why I put n is greater than or equal to 2 on all of these?
No. Because you just want to.
Because we only use this for the second term on. We do not use this for the first term because the problem gives us the first term. And you can't have negative terms, so I don't include negatives. So the n greater than or equal to 2 is just saying only use this formula for the second term and beyond. So those are 2 different problems. Let me give you a couple of minutes to try that. And then I'll show you how you can write your own recursive formula. See, that red pair of scissors. Thank you. It's okay.
Maddie, you know how to do this.
I have no idea.
Let me finish this and ask Mr. Taylor for
Wait,
and then
Mr.
I'll
Taylor?
Yep.
I know how to do it, I just don't know how to put the things in the
No, we can't come into our
Well, you
calculator.
don't have to do that.
Just
The
set
answer
this
is just
graph
the
up
5
and then
numbers.
you
So
can
if you
do
can
it.
get to the 5 numbers without writing the table, you're welcome to do that. I'm just doing the table to show people what we're doing, but if you could just go straight to the 5 numbers, go right ahead.
No, I don't know how to do that.
Well, you just said you know how to get the answer.
I know how to get the answer through this.
Oh,
But I don't know how to put the numbers on this.
so n is going to be 1, 2, 3, 4, 5.
Oh,
And then
This is
I didn't tell everyone.
the first one. We don't do any math because it says the first number is
I
negative
went
2.
to 8th grade. I told 7th grade.
Next right here,
6th grade, which was the stuff.
negative 2 plus 4,
Mr. Masuda, their class
which
was
is
in the middle of a
and then
project.
the
or
next one will
something,
be 2 plus 4. And the next one will be 6.
Oh, no. Just let's get this written down first and we'll go step by step. Alright, ladies in the room, and write the second one down. Do it enough to draw you a little chart where we
No,
can
and
go.
then can I finish this and then I'll help you.
So, or could we do it during break? What is that?
can I help you?
You can do it during reading pieces.
Okay.
I just don't want you to miss any more class time.
Okay, so I'm gonna start off, so it's just gonna be at this
And like, if you want to
Or I don't have to do
I said,
I nice.
I already know too.
I'm
too invested in it.
2,
You
-2.
know, we were
Too
doing
invested
things.
in it. You gotta go buy
Well,
yourself.
We're almost through with the first chapter. She's got to see it through to the end.
Right, -2 right here.
No. Here you solve that, which is going to be 2.
Yeah, it's
Then
not-
solve
yeah.
that, bring it to yourself.
I got you.
Add 4.
Plus 4.
Plus 2.
6.
6 plus 4. All the way down.
Right here. Or
No, do it. Solve that.
Okay. So on this, it's gonna be the same setup. Okay, so you know
all those out.
it's gonna be what?
And then find out if it's geometric or whatever that is.
Mhm. It's gonna be -2. So now you know -2 plus 4, right? Because it's gonna be just like how we did here, plugging it out. But we're gonna be adding 4. And then you do that all the way through.
Mr. Taylor.
Oh, you didn't?
Oh.
No, it might have been your
I was
chair.
supposed to start doing
Should be arithmetic.
You get the right idea. You started. No, no, no.
Right.
Actually, these are still all correct. Because
I'm
negative
sorry,
2
you're
plus
-2.
2, or sorry, negative 2 plus 4 is positive 2. So the only thing that's wrong is these. This is number 2. Positive 2 is the second step. So the first step was negative 2. The numbers are the same. You just started with 2 instead of negative 2.
Are you
Negative 2,
okay?
2, 6, 10.
No, I'm not.
Mr. Taylor, I need some
There
help.
we go. You got it.
Was A equals A1 minus that equation would go right here?
Yes.
And then
Wait,
A
Mr.
in would go right here.
Good job, Ronnie. Good job.
Now
Yes.
we're gonna do the same thing on this one.
Okay, so right here, would you do anything with that?
That's what you
We're
multiply
gonna
the previous term by.
So
New
-4
one through.
by. I need a calculator.
She freaked
You
out.
did it right eventually.
Yeah, you did.
She freaked out.
You said negative 2 plus 4 was 4. But once you corrected that, you're fine.
Okay, thank you.
I don't.
You already do the bottom one too?
Yes. Oh, 4 of that one. No, no.
-4.
What's on here?
Yeah, I would give this, and then -1 plus 4.
So you did both of those already? I know you did the top one. That's
Oh,
right.
maybe
I'm
4.
asking, did you do the bottom problem?
You know, Z?
I got it.
Huh?
Would that be 4 or would that be 2? The bottom one would be negative
Do you
2.
know how to plug it into your calculator? Plug it into your calculator
Plus
the way it
4
is.
is positive.
And you know it's gonna be
Mr. Taylor, can you check mine?
Can it be
I
a
would
decimal?
love to check yours.
Arrows.
negative
It
4.
can be a decimal.
But would you rather it be a fraction?
Because your
Oh, no,
A
I don't have a
auxiliary
preference.
-4, so it's gonna be your
Just
just
Maddie,
like
those are
it's
perfect.
times
Yeah.
negative.
Yeah, it doesn't matter either way.
Because you remember on the last
Decimals
one
and
that we
fractions
just
are both
did, right
numbers.
here, whenever it's butted up on one another like that,
Yes.
you're gonna multiply them. So you're gonna multiply your -4 times what? Yes, babe.
My dad, he got
Wait,
me
so would
this
we do,
big part of
like, -4
Mm-hmm.
plus
Awesome.
-4, or
No,
Yeah, we're
the
gonna
second
do
one is
just like
multiplied by
this.
3/2.
So
So negative 4
-2
times 3/2.
-4.
So the first one, the plus 4, is that arithmetic or geometric?
geometric. No, arithmetic.
Wait, why?
Arithmetic, because what am I doing every time?
Adding,
You were
Adding
I'm
two.
adding 4.
I mean, yeah.
If you add something every time, that's arithmetic.
sorry, Zeke, I
So
told
this
you
one
wrong.
should have been
Sorry,
If you
Zeke.
add
It's all
or
good.
subtract something, would that
I was
be
like,
arithmetic?
And then it wouldn't the next one be
All
arithmetic
right,
too?
calm down. It's gonna be okay. The next one,
Would be
what am I doing? I'm taking the previous term and
multiply times 3/2.
multiplying by 3/2. So if I multiply by 3/2, the sequence will be geometric. So the first term was -4. Negative 4 times 3/2 is negative 6. Then negative 9. And then here's where we get decimals. Negative 13.5.
And then negative 20.25.
And negative 6.
These are fun.
Everyone that we've done so far has been arithmetic or geometric. Can you think what it would have to look like for it to be neither?
Confusing.
Oh, you're about a person.
Yes, you do.
No, we're not going to do any of these today. I'm just curious if you know what it looks like.
As long as we give you a setup of room.
Yes, ma'am.
Wait,
There we go. So if I combined these,
No, that's
I know
not
that.
right.
But you know that you're just
Don't be rude
plugging
about it.
in
You,
this one would be
I'm not
neither
saying no, that's not right.
and letters.
arithmetic
So,
Okay, real
And
quick.
then I'm gonna need you to write.
nor
Okay,
geometric.
so it's up there. So the first one
So
would
it's
be
the one
negative
that we
4.
did that
Okay, and then it would be negative
Yeah.
6.
negative
that how
4,
it's
yeah.
like
And then you do negative
A1
Neither.
equals negative 4.
Negative
Is that
times 3 over
That's what I
2.
did. Negative 6.
Yes.
Because
The
that's
time when you're
wrong.
multiplying,
Sure.
the one that starts with negative 4, that one is
2.
geometric.
Yeah, we have to double check.
We need to write the
how
neither
it's put in those
arithmetic or
We'll come back to it later. We're not going to do them right now.
Look at my notes. Aren't they pretty?
Can't spell. So let's go the other direction. Let's suppose I give you the first 5 numbers.
great.
Okay, I'm going to give you the first 4 numbers. My calculator isn't handy, so I'm going to give you the first 4 numbers. Could you write a formula that does that? Well, let me rephrase that, because I see some of you shaking your heads no. You can. Let me show you how. So what were the 2 things that we needed whenever we were writing out the sequence of 5 numbers?
An A1.
We needed A1, which was where it starts. Oops. We do not need anything to be typed. We need the first term, which was the A1, and what else did we need?
The AN equals.
Yeah, AN equals, which was the rule. What are we doing every time? That's the A to the N equals whatever. All of the ones we've done so far have been either arithmetic or geometric, so the rule is always going to be add something every time or multiply something every time. That is not true like in life, but it will be true for now. Okay, so the first term is really easy. Look at the list of numbers I gave you. Which one's the first term? Well, how about that? It's 6. That was easy. Here's the part that's a little trickier. What's the rule? So I want you to tell me in a little bit, Ellie, but first, by looking at this sequence of numbers, is it arithmetic or geometric? I know it's got to be geometric or neither, but it's geometric because I asked you to write a formula and you can't if it's neither. So it's going to be geometric. It's not arithmetic because it's not adding the same amount every time. To go from 6 to 24, I added 18. 6 plus 18 is 24. To go from 24 to 96, I don't even care what I added. I know it's not 18. So it's not arithmetic. So it's got to be geometric. Okay, so then phase 2, if it's geometric, what am I multiplying by every time? So the numbers are getting bigger, 24, 96, 384. That tells me the number I'm multiplying by is going to be bigger than 1. I'm not multiplying by a fraction every time. Ellie, what's the number? Very good. I'm multiplying by 4. We talked yesterday how you could figure this out. If I did 24 divided by 6, the second term divided by the first term, that gave me 4. 96 divided by 24 is also 4. 384 divided by 96 is also 4. We talked about that yesterday. So what is the rule here? I'm multiplying by 4 every time. What am I multiplying by 4 every time? The previous number. So the rule is 4 times the previous term, which is a n minus 1. So our recursive formula is, the first number is 6. The rule is, I'm multiplying the previous term by 4. And as with all of these, it works from the second term on. And before anybody asks, yes, you do have to write n is greater than or equal to 2 on every single one of these, or your formula is incomplete. It's not too bad because it's the same thing every time, but you do need to have that in there.
So it's always going to be n.
And then can we write this into the can we do the equation now? Like solve it.
There's no reason to solve it. I gave you the numbers. Right in there in the problem. The numbers are 6, 24, 96, 384. Like I already told you that part. You're right. We're not going backwards. I'm giving you the numbers and you're telling me what the rule is. Okay, so let me give you one of these to practice. Let's write a recursive formula. For the sequence. For now, when you're asked to write a recursive formula for a sequence, it will always be arithmetic or geometric. Again, that's one of those things that isn't true in life, but since we're just starting off, we're going to keep it simple and say it's always going to be one or the other.
Hello, everyone.
Hello.
Hi.
Good morning.
How are
I'd like
you
for you to say
doing?
hello to Mr. Adams, Ms. Hodge, and Mr. Ariola. They're our visitors here.
Hello.
They work with CASA, and they wanted to see our cute little school. And y'all are on the floor again. We kind of just do, this is what SBC's doing here. We don't have a lot of rules and that. So Mr. Taylor, wave hi, because you look just like
Hi.
all the rest of them. I stole him from Marble Falls. He teaches Algebra 1 and a little Algebra 2 because I think you have a couple that are
Geometry's it.
geometry. Okay. And they do, and then he makes sure that they stay on track. The rest of their courses are online except for their art and their PE. And so all of us jump in and help tutor. I'm the English teacher sometimes. And then all of the other teachers help in with tutoring if they're stuck online and stuff. And they're doing a great job. We're really proud of how well everyone's doing. Right?
Where does the online content come from? What do you log into for that?
Call it, what's it called?
Grad Point.
Grad Point. Thank you.
It's a nice way to learn. I always liked it that way too.
These guys all took their SATs, their pre-SATs, this list. When did we take them? In November? October? Wow, that long ago. I was so very
Congratulations.
proud of them. So we're really proud of that. And they're working on some of that as well and kind of looking at careers and things, right? Did you try the NBA web thing?
We did. It was so popular when we logged in yesterday that the website crashed, but I believe we can watch a recording of the live stream to see what it was about.
That might be good. Okay, well, I'm glad to know it was popular and you tried.
It was popular.
Good
Thank
deal.
you for your time.
Thanks, guys.
Thank you.
Was that the video that we were supposed to watch yesterday? But
Yes, we tried to get logged in, but the website crashed.
Wait, who were they again?
They were from Casa.
Yeah, awesome.
That's Spanish for house.
That's
That's all I know.
The whole piece, well, my house they
Mhm.
helped me like transition from my house to RTC and then that.
Oh.
So they're like fermented people.
So, what's the first term in this sequence?
6, 4.
4 is the first term. That part's pretty easy.
Mhm.
And so the next thing that we have to ask is it arithmetic or geometric?
It's geometric.
It's geometric because we're not adding the same amount every time. From 4 to 10, we added 6, and from 10 to 25, we added not 6. So it's geometric. So the next question is, what are we multiplying by every time?
No idea. Wait, 2.5.
That's 2.5. We can verify that it's the same all the way across. Do the third term divided by the second. The fourth term divided by the third. You should get 2.5 every single time.
So it would be.
So we're multiplying by 2.5. So AN equals
2.5.
2.5. Or if you used fractions, you could have used 5/2. That's fine. Like that.
Doesn't matter which way you go, like fraction.
No, I don't care if you use fraction or decimal. So there it is. That's our formula. Oops. And that's all you'd write for the answer. Okay? Okay. I'm going to give you a handful to do. I want you to do these on a clean sheet of paper. This is going to be your assignment for today.
It's due Tuesday.
It'll be due Tuesday. Yes, ma'am.
At 2 a.m.
You know what? Let me. No, not at 2 a.m. I think I'm just going to pull some out of the book today.
It's okay. Okay, calm down. You're okay.
Hey, I want my ruler. My
Okay,
teacher's ruler.
Here.
Let's just do the first 5. That looks pretty good.
Okay. Let me finish all this stuff.
Yeah, I like that. Let's do the first 5.
Okay.
Any questions?
And I was writing that in my